An abridged history of light. Is light a particle? Is light a wave? This is a question that has been the subject of much debate over the past 300 years. Depending on the experiment or observation, it displays the behavior of a wave, and other times displays the behavior of a particle. Let's learn a little about the history of the nature of light. In 1704, Sir Isaac Newton published Optics, which described light as a group of tiny particles that he called corpuscles. Newton was able to explain properties such as reflection, refraction, and dispersion with his particle model. However, certain properties of light, such as diffraction, the bending of light around objects, could only be explained by thinking of light as a wave. This theory is credited to Christian Huygens, with work done by Robert Hooke and Leonard Euler. In 1803, Thomas Young's double-slit experiment showed that light acted as a wave. Maxwell then published his 4 equations of electromagnetism in 1861, where he treated light as a wave. Then came relativity and quantum mechanics. In 1900, Max Planck explained blackbody radiation by stating that light was emitted only in quantized bits of energy, like a particle. This was the beginning of quantum physics. In 1905, Albert Einstein published a paper on the photoelectric effect, for which he later earned his Nobel Prize, which confirmed that light came in discrete packets of energy. These packets of light energy were named photons by Gilbert Lewis in 1926. So light was explained in classical physics as a wave, and the new field of quantum physics brought back Newton's idea of light as a particle. Then, in 1927, at the 5th Solvay Conference on Physics, the most prominent physicists in the world met to discuss the new quantum theory, including Albert Einstein, Niels Bohr, Max Planck, Marie Curie, Erwin Schrödinger, and many others. A picture of the participants is shown on the next slide. Here is a picture of the participants of the 5th Solvay Conference on Physics. Quantum electrodynamics fully integrated quantum physics with electrodynamics, electricity and magnetism. Sin Itiro Tominaga, Julian Schwinger, and Richard Feynman received the Nobel Prize in 1965 for this theory, where they described the interactions between light and matter. Here are Feynman's words on light from his book, QED, The Strange Theory of Light and Matter. I want to emphasize that light comes in this form, particles. It is very important to know that light behaves like particles, especially for those of you who have gone to school, where you were probably told something about light behaving like waves. I'm telling you the way it does behave, like particles. You should have a feel now for how light has been the subject of much experimentation and dispute. Even now, people talk about the wave-particle duality of light, and as you go on in physics, you will see a similar behavior of elementary particles, such as electrons. A good way to think about this is that the actual world we observe with our senses and instruments is way more complex, and it is difficult for us to explain what is really going on. We will first learn about the wave nature of light, and then the particle nature, both depending on the type of observed phenomena and experimental data.